Hello, everyone. Hello. We want to get started. We have a great presentation today. Gordon, Hunter, Chet, and Achilles are going to talk about PolySwitch. Some other events that occurred this week. Officially, Menlo Park is shut down as a Raychem site. So they had an official closing this week. We lost several more Raychemers, passed away. Moment of silence. All right, now let me give you a little background on these people. First, Chet. I knew Chet before I came to Raychem. I had lunch with him, and he was the guy talking about plastic heaters. I was a heat transfer guy for Raytheon, and his roommate, turns out, worked with me. So I met Chet, and he was driving an American Motors Hornet, and I thought, who the hell is this guy driving this car and talking about plastic heaters? It was a green Hornet, yeah. See, that's even worse. But Chet started at Raychem in 1972, and very quickly got involved with what I would call his strength, which is innovation. He's one of the few people I know that has original thoughts, and I mean that. That's very unique. He worked for Raychem for 30 years, mostly in the heat tracing business, but in several other areas. Went to Shell, worked for Shell for a number of years, and since has been retiring, he has been a consultant. He's volunteered to give the talk next week, not next week, which will be on the IEEE award that was given, the Milestone Award. So I won't take any of his thunder from that. Achilles is the second presenter. He joined Raychem in 1983 in Swindon, fresh out of university. He moved to Otterburn for a while, and then he joined Raychem Electronics in Menlo Park in 1986. He joined the circuit protection, PolySwitch, in 2003. And he's now Vice President of Consumer and Automotive Markets for Bourne. Third is Gordon Hunter. Gordon started in Raychem in 1979 in France. Logical place for an Englishman to show up, but that's all right. Moved to Redwood City in 1980. 6 years in product management and project sales. Then he moved back to Europe and then back to the United States to run PolySwitch in 1992. He left Raychem, in 1999 when Tyco bought us, he became the head of Chemolex. Luckily, a year later he left, because then I became head of Chemolex. He moved to Chicago and took over as president of Littelfuse, and is currently chairman of the board of Littelfuse. Without further ado, let me give the mic to Chet and
Gordon's gonna do a pre-ramble.
So
I'm gonna get my chair.
you're gonna work the computer for us?
Oh, yeah.
Good. Teamwork here. So when Jim asked me to talk about the history of PolySwitch, first thing I thought of is Chet. Cannot be talking about the history of PolySwitch without having Chet be the key part of this, because what I tried to do was, if you can do it the first slide, Jim, was put together an agenda that sort of shows the history, which Chet will talk about, the invention, the work together with the Chemolex business, the conductive polymer real evolution, and And then I, as Jim said, worked for PolySwitch during the 90s and thought I would continue that discussion about what happened during the 90s. And then fortunately we have Achilles, who actually, just as I left, came on board and was there during the 2000 to 2010 period when it was owned by Tyco. And then after 2010, I'll pick up the story and the ending of that. So that's the format that we have, and we'll take any questions at the end. I'll hand it over to Chet.
Okay, I'm going to talk about the early years. This is one of the early poly switches that I found in the photo library. Next one. So this is a memo that was written by Paul Sherlock. Paul Sherlock wrote a book on innovation, and a lot of it's about Raychem. But anyway, Paul and the R&D guys sent Paul Sherlock back to Chemolex in Danbury, Connecticut, to look at whether we should buy them or not. And then we did indeed buy them in 1969, and we got, the guy on the left here is Bob Smith Johansson. Bob Smith Johansson is a Norwegian that was a cross-country skier, but his dad was the famous cross-country skier. His dad was Jackrabbit Johansson. He died at 110 years old or something and set up all the cross-country race formats for a couple of Olympics, so it was interesting. And so Smith Johansson was trying to make a better ski wax, and back in the day, the old skis were wooden with metal rails, and he said, graphite, that's a lubricant. So he slapped some graphite on, and he said, I want to see how thick it is. Maybe I can measure the resistance. So he put some voltage on it, and voila, it was a parallel circuit heater. So that was the first parallel circuit heater. And then he made a product called ElectroWrap, and he had this idea back then of making a silicone-based self-regulating heater. So after we bought Chemolex, we moved Jackrabbit's son out to California, and he got in cahoots with Jock Walker. And Jock Walker had just put a coating tower into wire and cable, and it was just a terrible experience, he thought. So he said, we can't do coating towers on this stuff. Why don't we throw some carbon black into a polymer and see if we can make that work? And indeed, it did work, and so that's where the first auto trace came. Next. And the history of auto trace has been amazing over the years. It's a huge business, solved a bunch of problems, and we just unveiled an IEEE plaque at 2501 Bay Road, which is where the manufacturing facility was and still is for auto trace over the years. And this turned out to be the 200th IEEE plaque, milestone plaque. They're only doing them on significant inventions, and they have to be of benefit to humanity. So I spent 3 years trying to convince the historical committee that this is worth doing. And people on the historical committee are mostly communications guys and microprocessor guys and that, but this was really one of the first nanotechnologies, because when you look at the internals of auto trace, it is indeed a nanotechnology. So anyway, I was hired by the guy on the left here, Fred Grafton, who is shown here telling me how big my bonus is going to be. and then I joined Chemolex. And Grafton said, okay, your job is to find out other uses for the autotherming effect. And I said, okay, we can do that. But there wasn't an internet or anything there, and finding things out were really tough. But there was a thing called the Thomas register. How many people remember the Thomas register? Right, there's everybody. So anyway, that was one of my source documents for this. Went to trade shows, Stanford Engineering Library I spent some time at, and also looking at what UL wanted to do for safety on a bunch of electrical devices. There were 3 people making barium titanate doped ceramics, which had the same type of PTC effect, positive temperature coefficient effect, that the stuff I was trying to make out of conductive polymer and Texas Instruments, Murata, and Sprague were all making these. So anyway, so Grafton said, okay, you know, your job here is go out and figure out what we can do with this stuff for other applications. So I broke it down to the 4 different categories up there on the top, on the left. It was first called the Future 55 list because there were 55 entries in the list back then, and this was tough because I always had my secretary typing it because there wasn't any spreadsheets there. So it was really tough. I said, no, change this one, put this one before that one, so it drove her nuts. But anyway, there was 4 categories. One was to be marketed. That was just sort of putting another name on what we had for AutoTrace. To be engineered to figure out what the thermal output would be in concrete instead of on a pipe. To be developed, to really change some of the characteristics of it, and to be invented. And if you look at the first 2 here, type 4 to be invented, we had a thermoelectric autotherming resistor and we had a thermoelectric autotherming switch because we were trying to figure out the 2 different characteristics of the system. One, they were going to do a resistive line cord, which is like the stuff you have for charging the iPhones now, the wall warts. And the other one was just a switch to turn on and off. And so there were all these things, and it turned out that the list, the little tiny list on the list on the left that you can't read, adds to 747. And both Paul and Bob Halpern liked the number because they were selling wires on the Boeing planes. So all of a sudden the thing became the 747 list. So that was good. Okay. So what were the applications? In 1973, I found one for a degaussing coil and one for a motor starter. So I basically said, well, that's what we want to look at doing. Next one. This was a Ptc Resistor, they called them, made by Murata. Next. This was a capacitor that disconnected a coil and a motor for a motor starter. Next. And this is the one that was interesting. I just spent a lot of time on it. This is the back of a color TV back then when you had a degaussing coil. The degaussing coil, when you turn your TV on, it sort of buzzed because it had a coil in there that was erasing the magnetic field that was still on the mask for the color TV. And you couldn't just turn it on and off because the 60 hertz would stop somewhere and leave magnetism on it. So this little thing over here, you had to feather it down to nothing, and that was a really good thing for the PTC to do because it'd turn it on, it'd heat up, and the current would drip off. Okay, so I was there, and Grafton kept saying, hey, what are you doing on this? I said, don't worry. I hired a PhD from Berkeley, and he's going to come in this summer and be a summer student. And so my buddy, Steve McBride, came in, and he gave me 14 pages of Maxwell equations on why this should work. It was totally useless. So that didn't work. That was my first venture into using physicists to try to develop products. Okay, then what happened? Well, we were mumbling along. I tried to make some by putting a bunch of AutoTrace in series and in parallel, and that didn't work very well at all. And Paul said, well, you're not doing very well at this. We're going to put it in corporate R&D. And so I had a choice. I could stay at Chemolex or go to corporate R&D. And I stayed at Chemolex because AutoTrace was just blooming then. It was just going off the charts. And it seemed like a good place to be for the growth. And I could do some stuff there. Okay, next one. But it went to these guys over in R&D. Alan Gotcher and Henry Simon. Alan's there trying to pound on the poly switch with a phone to see if he could change the resistance. And Henry thought if he could lick it, he'd get the resistance to change and bring it into the specification. Okay, Paul wrote an article. They interviewed him, and there's a huge 5-6 page article in the Harvard Business Review in 1990, and he talked about the 747 list there. And the real winner on the whole 747 list was the poly switch, which was developed. We could make all of the different ones in type 1, 2, and 3, but they weren't that different. And the really different one was being able to to make an RT curve in the poly switch that would really give you a different function, not just heat, but to be controlled. And it was really the second thing that Raychem did. The first one that was an active product was AutoTrace, and the second one was poly switch. Before, it was mostly insulation and different things to protect the electrical connectors and that type of thing. Okay? Okay, this is my final deal with PolySwitch. I was taking care of the hazardous area approvals back at a factory mutual, and we were doing stuff in what was called Class 1, Div 1 areas. And Motorola at the time had a wireless microphone thing that they used, and they said, well, you got a poly switch in here, but we also have a resistor in series with it, and we could get the resistor out of there, the battery'd last longer. Well, what happened was they said, well, can you guarantee the poly switch is going to last forever? And I said, it will, but I'm not going to guarantee it. That's too much liability. So we didn't do that. So that was my last poly switch thing.
My name is Lee Middleman, and I was at Raychem from 1976 until the late 1980s. Recently, Chet Sandberg and Gordon Hunter put together a presentation about the history of PolySwitch. I would like to fill in a gap between their presentations to highlight corporate R&D's role in the PolySwitch success. In 1976, circuit protection research began in corporate R&D, and as a physicist, I was hired to explore this technology from the perspective of device design rather than materials. And I formed a team of Raychem scientists and hired some physicists and electrical engineers to do that. The team included Frank Doljak, Don Pettengill, Peter Van Konynenberg, Joe Evans, and several technicians. We began by prototyping designs using existing conductive polymers. We developed test equipment to analyze and characterize those prototypes, and this was an important factor for improving device performance. When you understood how the device failed and how it performed, you could then feed back into your design and also ask the conductive polymer scientists to modify the RT curve, resistance temperature curve, providing more definition to the required height of the curve, the slope of the curve, the initial resistance. After numerous tests, the team recognized that the need to focus on devices of low voltage and low power applications. Although Raychem focused on high power and high voltage applications, we needed to begin at a lower level in order to develop device performance. The marketing team of Henry Simon and George Balog began focusing on those low voltage applications and brought to us numerous customer needs. Here's an early piece of test equipment, both testing the performance as well as the aging characteristics of the device. You'll notice that it's shielded in plexiglass because failures could often be catastrophic in those early days. We built many test stations to cycle the devices on and off and see how they performed as they aged in their resistance value and how they failed. We also characterized the devices at different temperatures in hopes of accelerating their aging and discovering their failure mechanisms. Here you see an oven on the left-hand side controlling temperature, and on the right-hand side, HP equipment and early computers used to monitor the devices and their failure mechanisms. We worked hard, but we knew how to have a good time too. Here's George and Henry slicing up a huge sandwich for us. During those early years in R&D, we made significant improvements in the PTC polymer composition, the physical configuration of the devices, the electrode design, the ability to test, and it was a team effort incorporating the input from physicists, chemists, polymer chemists, process engineers, and electrical engineers. Here are some early devices that were extruded with metal mesh electrodes, then chopped into pieces, welded to wires, and then encapsulated. Raychem had a very strong patent and proprietary protection culture, and as we developed key elements to the device design and manufacturing, we filed many patents around the world, and this was a key element of our development plan and an essential part of the success of the program. Many other people in R&D assisted the core team. To name a few, Andy Al, Eddie Blake, Bob Fouts, Alan Gotcher, Meg Gertschner, Steve Jacobs, Bert Miller, Andrew Tomlinson, David Vroom. And of course, none of this would have been possible without the support from corporate management. That corporate management included L. Brown, Jim Spradling, and of course, Paul Cook, shown here on the left with me, Peter Van Konijnenberg, and Bert Miller at a dinner. To create successful devices, we had to learn the key elements of thermal load and characteristics, potential arcing failures, and device resistance and aging. Encapsulation in epoxy resin turned out to be very significant, with many unexpected improvements in aging, well beyond oxygen permeation that had been predicted. Some examples of early encapsulated devices are shown here. Failure analysis was a key element of the device design, particularly with the mesh devices. On the left you see a cross-section of such a device, and on the right you see the hotlining behavior that occurred, where the hotline didn't necessarily go directly across the product, but concentrated at the electrodes. Successful practical designs resulted in early customer orders, and so a small prototype facility was built in R&D under the leadership of Jacques Walker and Alan Gotcher. One of the early applications was to protect batteries from overheating and damaging or exploding. This was the Motorola battery application. In the prototype manufacturing, many things were done by hand. Here we were labeling the devices. Here Eddie Blake and I are looking at poly switches used for a mobile radio application. As we scaled up prototype production and customers had success with the product and placed more orders, the decision was made to form the poly switch division. Some people moved to the new division, and others, including myself, remained in R&D to explore new products. It was important to move it onto a standalone basis as a business, get new leadership, and to proceed to make a successful product. I think this was one of the best transitions from corporate R&D to a division that I have seen. Thank you.
So I'm going to turn it back over to Gordon, and here he's trying to interview a couple drunk Norwegians for the Polyswitch group.
Thanks, Chet. That was Chet and I at the Winter Olympics in Oslo together, having some fun, if you remember that photograph. So that was the time through the 80s. Jim, if you go to the next slide. So the 80s was a time of growth based on all of that 747 list and trying to prove that the Polyswitch device could actually work, and the Motorola application was one of the first ones where we really saw the need for battery protection as batteries were becoming more a part of life, and we had more and more mobile devices that needed higher energy density batteries. So the 80s was a period of growth for the product, but not profitability, and we got into the 90s, and this was really like a large startup that had not made any money, not being profitable, and there was a time to sort of make some changes. So picking up in the 90s really became the growth and profitability years. Next, Jim. So there was a new leadership team were put in place. Just hit the next bullet points, Jim. There was really a time of global expansion, and that was really important. It was a time that Japan was starting to become a critical part of Raychem, and there were some very good people in Japan led by Jun Ishioka, and some great customer relationships there, especially around the battery business and the motor protection business, two of the great applications where a Polyswitch device was the perfect solution to any other kind of circuit protection. There was a large investment continued in product development, making these products both in Japan and in Menlo Park. And as we started to scale up engineering, midway through the 90s, really a focus on operational excellence, much better manufacturing processes, and some cost reduction. And in the mid-90s, I also talk about what I regard as the most extensive strategic plan ever put together in any business that I've seen. So next slide. So the leadership team, there was a transition at the time. Some people who you may know, you may have worked with. Peter Brooks, Mark Thompson, some very good technologists there. Chuck Coffin running the product management business. Tony Fang, a brilliant technologist for conductive polymers. And Jun Ishioka in Japan. A very good global team. It was a time of global expansion, getting people in Europe, Gilles Gozlan, who developed some of the products. So it was a phase of making the business global, which, you know, as we all know, Raychem was at the forefront of being a global company, well ahead of many other companies, and for its size, it was extremely global and able to attract really good talent around the world. So people of the caliber of Jun Ishioka and Gilles Gozlan in Europe, these were people who were top talent, and they in turn attracted people from the best schools to develop products around the world. Next slide. So that was the years, and this is when I came back from Europe to the Polyswitch business, and one of the very first meetings in the early 90s, I remember, was in Harry's office. The big decision, shall we invest in a factory for manufacturing in Tsukuba, Japan? It was a big deal at the time for the company to invest and build a factory, and the lobbying was that, you know, Japan was a place of, you know, a lot of technology development, a lot in the way of battery technology, and a lot of customers in Japan would only be buying from us if we were to really manufacture there. So we made the decision, a big investment decision at the time, also led by Jerry Delaney and Wells Whitney, two guys who had worked in the conductive polymer business in Chemelex, had gone over to Japan and really convinced Harry and the team that we should make that investment. And then once we decided to put the money down to build a factory there, we decided Asia was a place for expansion, sent over 3 more expats, so heavy investment in people as well as technology and factories. Chuck Coffin, Tony Fang, and Jim Witham went over there to run product management, technology, and build an Asia sales force. We moved George Strohmeyer, who was a very good sales manager in the telecom business, over to Europe to build up a European team. We started to sell directly. We had a relationship of selling the product through a company called Bonds on a private label basis, but we really made the decision that if we wanted to be a significant player, we would have to actually go on our own through our own channels, and we discontinued that relationship, which caused some ill feeling and caused, in fact, the beginnings of a long lawsuit with Bonds that went on for many years. And then we finally, towards the end of the 90s, opened up in China, which we realized was also a large opportunity for the business, as well as a place that we could ultimately do manufacturing. Next slide, Jim. So that was where we were investing also in Menlo Park. The Building H building was outfitted with a beautiful lobby, a beautiful factory behind it, a huge investment there, but a place that really did impress customers when we brought them to Menlo Park and brought them into that new building. So that was the first phase of investment. Next, Jim. And then a 69,000 square foot scuba plant, absolutely state-of-the-art, as you would expect to have in Japan, for the Japanese customers to come and see where their products were made in Japan. Next, Jim. And then later in the 90s, we built a plant in Shanghai with the same brand image and the same appearance to the factories in Menlo Park. Next. So this was also a phase, as I mentioned, of a lot of product development. Peter Brooks and Mark Thompson in particular leading teams around the world. And you know, at that time, it was really the beginning of really the internet in the early 90s and the beginning of people buying a new computer every couple of years as we went from a 286 to a 386 to a 486 and Pentium. Every time we did that and Microsoft would upgrade the operating system, people were refreshing their computers on a regular basis, and we had a lot of content in each of those computers. So the growth of computing, the early years of cell phones, the early years of lots of electric motors inside vehicles, there were a lot of things in the market at the time which were all good opportunities for circuit protection. And with good marketing people around the world, we realized that we could get penetration into those customers and develop products like the Mini SMD and the TR600 and the low resistance devices, so-called low-row battery strap. We had very good relationships with a lot of customers by having a very good team, especially in Japan, and we tried to replicate that with key customers around the world. And then Joe Young, a very good operations guy, really tried to ramp up the capabilities to quickly ramp up new products in the factory, make sure we had impeccable quality levels, and really start to focus on operational excellence and cost reduction. Next. I mentioned that we had this, a very strong position in the market, a strong position in Japan, but we also realized that it had taken quite some time to get to that level with regard to the length of some of the patents that we had, and that at some stage we were not going to have the patent protection and be the only player in the market with a polyswitch device. And so we really thought, how are we going to address this business after we have less patent protection and the market expands and other competitors come into the market? So a couple of guys, Rob Palmatier and Gary Weissman, did what I would say was the best piece of strategic planning work I've ever seen. They really involved a lot of people around the company, all different levels, different functions, and really had them work through extensively what are the potential outcomes and what should be the strategy of this business to make it successful, because it was growing, become very profitable, but it didn't necessarily fit with the channels of distribution with the rest of the Raychem products, with the tubing business, with the wire and cable business. It was a components business and it needed really its own strategy. And what we were also seeing at that time is that semiconductor devices were growing, and there was a potential threat from a semiconductor device having the functionality of a polymer PTC, although we had that leadership position. Next, Jim. Just a couple of slides from that strategy work. Sort of interesting, to reflect back as I've been around this business. These were slides back from 92 and 95. How relevant they are today. It still is extremely good work, but how small the industry was. The semiconductor business being a $30 million business at the time. What we saw, the compounded annual growth rates of semiconductors at 17% over that period really outstripped the passive and electromechanical business, which sort of showed that a lot of capability around semiconductors was really going to be a threat to the business. But overall, the components business was predicted to be a very healthy growth business for the next few years. Next, Jim. We looked at it globally. We looked at our relative market share for the applications that we could have. And what we found, not surprising, the two places we'd really focused, in North America and in Japan, we actually had a very good market share, good position. But we also recognized that, and a fairly reasonable position in Europe, but the rest of Asia, and especially in China, were places we hadn't really penetrated. We hadn't really built the Chinese team in the way we built the Japanese team. And we started to find that the rest of Asia, especially China, was the biggest opportunity with the fastest growth. And so one of the actions of the team that we sent to Japan was to build a Taiwan and China and Singapore organization to try and capitalize on that, which has really worked out also to be very true more than 20 years later. Next slide. Won't go into all of the detail, but just the level of detail from a slide that I looked at, how we went through looking at best in class of how to run an organization, what the costs were of all of the functions in the value chain to operate this business, how many people we had, how to benchmark that against the best in class organizations, and look at how many people you should have around the world in different functions to make a profitable business. And at that time, the operating income of the business, we had got up to 28%. So it was a very profitable business. Our real concern was, could we maintain that level of profitability in a world where the business would get bigger and have a lot more competition? Next, Jim. So we build up a whole list of scenarios saying what will happen. Will there be increased competition? Will the patents expire? And we have multiple polymer PTC competitors. The third bullet point, which really, I think at the time in the early 90s, are we going to see something called smart power, meaning a semiconductor device, really be an alternative to polymer PTC? And will it ultimately be lower cost because semiconductor costs are coming down so dramatically? Will we face the potential to be displaced by semiconductors, which in some segments has really worked out? So we really debated that long and hard, and I think it was a very good strategy process to be able to think out 20 years from now, not just a couple of years, and that actually has become true. So we developed a list of strategic options. Whether or not we become the technology leader, whether we become just the supplier of polymer PTC material, or whether we try and make a complete components business. Next slide, Jim. Sorry, my fault. So anyway, the conclusion was, what we wanted to do was really try and make the business multiple components, not just polymer PTC, but be a global leader in components for circuit protection. Next. So that was sort of the story of the 90s, all those market segments of computers and cell phones and automotive electronics all growing. So we had great tailwinds, great people around the world, especially in Japan and ultimately in Asia. So the 90s had been a tremendous period of growth for a very profitable business. Next slide. So next. So the end markets were all growing. And then we came towards the period of next stages of expansion for our strategy in the late 90s. And as we all know, in the late 90s, a different event happened. In fact, there were a couple of things happened. There was the tech wreck, which impacted the business, but there was the other wreck, which was the Tyco acquisition at the end of the 90s. And so we have Achilles, who came on board at that time, and we'll pick up the story of after the Tyco acquisition.
I'm going to talk about the wreck. So I joined Polyswitch, it was summer of 2000, and I remember at that time the business was mature, was profitable.
Keep the mic up, please.
Oh, I'm sorry.
Just put it up to your...
Okay, sorry. So the business was mature in the summer of 2000, was profitable. There was a well-defined strategy, as Gordon explained. But there was a big difference. We had now a different leadership time. Next slide, Jim, thank you. We had new people. You can see here the first 2 years, 2000 to 2002. I call them the challenging years. The leadership team at the level of Tyco, it was Dennis, Federman, and Jürgen Gromer. And I remember Ed Federman, who was the CFO of the company at that time, walking into my office, and he said, well, we're not interested in new product development. This is a waste of time, unless it is something you can do very quickly. We want you to go after acquisitions very quickly, very aggressively. The next thing we knew, we woke up one day and we found out that Raychem Circuit Protection had acquired a magnetics company called Coev, like Coevolution. That was not part of our strategy. Gordon explained the strategy of becoming a broad portfolio provider of electronic components for circuit protection. So we were surprised by this. But also that was a company based in the US, relatively small size, with manufacturing facilities in the US. And it was in a declining market segment, it was telecom at the time. And they were making magnetic components like inductors and transformers. And they were not profitable. And we had plenty of quality problems. So that did not go very well. We had to divest this business a couple of years later. But in the meantime, also we have big scandals at Tyco, and I am sure you're familiar with that. Ed Federman, the guy who was pushing us to make acquisitions, declined in disgrace because he was cooking the operating income numbers. And then Dennis, you all know what happened to Dennis. So that was not a very good time for Polyswitch. Then, on top of that, we had a market decline, a significant market decline. So the Polyswitch sales revenue went down quite a lot. And that impacted also the new product development and acquisitions. We could not really make any acquisitions any longer. Also, we missed a couple of big opportunities. At that time, Tyco International decided to sell a patent, or 2 patents, based on MOV assemblies for surge protection. So they sold those 2 patents to one of Raychem reps. And because Tyco thought that those patents are useless. And the rep went on to make those devices based on the 2 patents of Raychem, and he created a $200 million company. He called that Raycap. If you see Raycap, it exists today also. It looks like Raychem. It's red, it's the same italic calligraphy, so it looks very nice, and it is a very successful privately held company today, very profitable. So another mistake of Tyco at that time. Now, after 2002, with all the scandals, Dennis was out, he went to prison, and Ed Federman was out, and we had a new leadership team. We had Ed Breen, and Jürgen Gromer was still there. Now, those are the relatively good years, because Ed Breen came to us and he said, you know, you cannot do acquisition anymore, so stop. So everything needs to be through organic development. So we went back to our roots, like material science, polymer science, niche markets, development, patent applications, back to what we knew as Raychemers. And that was good. We spent 5 years doing this, and we grew the business from around $200 million in 2002 to 300 million, roughly, those are rough numbers, in 2007. So $100 million additional revenue based on material science, polymer science. All of that had to do with polymer PTC, extending the portfolio, like more voltage, more current, small size, surface mount, and so on, and different applications as well. We developed a lot of application knowledge at the same time. So that was relatively good. And then in 2007, there is a major development. Tyco splits into 3 individual companies. One of them was Tyco Electronics. So we became Tyco Electronics. And the new CEO of Tyco Electronics now is Tom Lynch. Tom Lynch is a guy who came from Motorola, and he brought a lot of Motorola executives with him. So it was like kind of our Motorola years, because everything was influenced by the Motorola mentality. He brought with him Jeff Ray. Jeff Ray was part of the Motorola guys, and Jeff became the overall leader of Polish rates, of Raychem Circuit Protection at the time. The name was changed from Raychem Circuit Protection to Tyco Electronic Circuit Protection in 2007. Now, the good news here is that we had a lot of hope with Tom Lynch, because he said, okay, you guys, you were successful. You added organically $100 million in 5 years. The operating income was good. It was close to 21 to 22%. So you know how to develop things. He said, I want you to continue your development effort. So that was excellent. On top of that, he said, you have proven to me that you are good with ideas on acquisition. So I want you to go out and evaluate, again, acquisitions. So we created an acquisition committee at this time to evaluate different technologies. And at the same time, Tom Lynch said, we are a big company. Tyco Electronics is a big company. Please don't operate like a standalone business unit. Come to us. Let's talk about the leverage. We can help you, either introducing you to vertical markets or helping you with negotiations, having synergistic sales or synergistic negotiations, and so on. So, and then when he described those 3 things, he said, oh, by the way, now I want you to go from 300 million to 600 million in 3 years by executing my strategy. So that was the challenge from Tom Lynch and Jeff Ray. Next slide, Jim. The strategy is what Gordon described. Gordon, it has never changed after you left. We had 2 major planks you can see here. The first one was to maintain the leadership in polymer PTC. We were the undisputed leaders in polymer PTC. And we thought we can do that by doing new product development, new market development, and cost reduction to remain competitive. So we executed pretty well this particular plank. The second one was to expand position in non-PPTC, beyond PPTCs, but in electronic components, doing circuit protection. And we thought alliances like private label business or license in general and acquisitions will help us with this. Next slide, please. So we went into an extensive evaluation of what we could do in circuit protection. And this is kind of a simplistic diagram here showing what we did. We were taking the annual growth, the estimated annual growth, also how profitable the business may be. And then we evaluated all those different technologies, 16, I believe, different technologies, all of them in circuit protection. So basically, the fundamental strategy was to go beyond overcurrent protection, polymer PTC, into over voltage protection with other major technologies like GTTs, those are gas tubes, or with semiconductor devices, thyristors, or with TVS diodes, or with MLVs, those are multi-layer varistors, and so on. So we worked almost for a year in that committee to create a lot of knowledge around those technologies, how profitable they are, the growth rates, and also target companies. We thought the best company to acquire was Littelfuse, but that was rejected. And as you can see here, the biggest circles, the bubbles, are with auto fuses, automotive fuses, but also with bimetals for home appliances. So based on this, next slide, Jim, we selected the short list of what we're going to recommend to Tom Lynch and to Jeff Ray. And you can see here we recommended electronic fuses. This is basically the single-shot fuses for the electronics market. We recommended bimetals, mainly for home appliances, a huge market, like we estimated at the time $1 billion of market. And then extension of PPTCs, like hybrid materials and different PPTCs as well. GTTs, those are the gas discharge tubes for telecom applications, over voltage devices, over voltage protection devices. MLVs for ESD protection in many, many market segments. And also we had some specific projects like polymer ESD and silicon ESD and so on. So that was the short list. For this short list, we made a book, a business case, a solid business case, and we presented that to Tom Lynch. And next slide, Jim. And the result was everything was rejected. Now, why everything was rejected? Because we thought we had a really good business case. It was not the growth rate, it was not the profitability, it was not because we had wrong assumptions. It was because, according to Tom Lynch, it was not a very good strategic fit with the company. Tom Lynch was already taking the company to a different direction. He wanted to do connectors, connectivity, and sensors. So he did not really see how a company like Polyswitch, like overcurrent protection, or even circuit protection in general, could fit very well with this. So basically, everything was rejected. We made, I remember, a proposal to acquire a silicon-based Polyswitch. Gordon, you mentioned semiconductors. And that company was run actually by Jim Witham, an ex-Raychemer. The name was Fulltech. And that was rejected as well. That was a startup at the time. And the reason for the rejection was that we are Tyco Electronics, we are into passive components, we don't want to deal with semiconductors, with foundries and wafers, no way. We want to remain into passive components. So that was rejected at the same time. What Tyco Electronics told us to do is to go and evaluate those different technologies through private label businesses. So we created a number of them for bimetals, for ESD devices, for GTTs, for MOVs, for single-shot fuses, and we created a small business, but it was not very profitable. It never really grew to a significant business for Raychem circuit protection. And then talking about the Tyco Electronics leverage. So when we started going together with Tyco Electronics salespeople and business development managers, we realized actually that the Raychem brand was stronger than the Tyco Electronics. It was not a good reference to say we are part of Tyco Electronics. And it was the other way around. We were helping Tyco Electronics as opposed to Tyco Electronics helping us. But also what we found out is that, let's say you go to do some negotiations for a business with a customer, and we have, let's say, polymer PTC, and we want to add MOVs, let's say as an example, or thyristors. Well, we may be a preferred supplier for PPTCs because of our excellent pre-position and relationship, but we may be unknown for MOVs. So that did not help. Tyco Electronics could not help us doing anything. If they had a good position in connectors, it did not translate into a powerful position in negotiations to do more businesses in other product lines. So That proved to be a myth. It never worked out very well. So if I jump to year 2010, so it became very clear to the leadership team that Tyco Electronics did not have a real interest in circuit protection, in Raychem circuit protection. And they were asking us more and more to be more profitable, to increase the operating income every year, not doing really a lot of new product development. So our assumption was that Tyco Electronics wanted to divest this business, to sell the business to somebody else. That assumption was correct. At the time, we see a lot of people now leaving the company from all functions, from sales, from marketing, from technical. Some of them left the company altogether. Some of them went to different business units. So that's the story in the first decade of the 21st century. Gordon will tell you now about the happy ending.
Thank you, Achilles. It's always good to have someone who lived through that period and saw it real firsthand. I was on the other side of the fence, having moved to Chicago to run Littelfuse in 2003. And we did end up buying the Polyswitch business. But the next slide, I think, is important. These are 6 of the current vice presidents at Littelfuse. They're all ex-Raychemers. And so what I did when I went to Littelfuse, which is a Midwestern fuse company, when I went there, was really trying to bring a lot of the values that I had learned from Littelfuse and bring a lot of the people. Deepak Nair, who started out in the labs here in Menlo Park, developed some of the TR250 and TR600 products. Deepak then went into sales in Raychem, as we did, moving people around. He moved to different locations. He's now running a $400 million electronics business, which includes the Polyswitch business, and is just doing an outstanding job. Ryan Stafford is setting up the legal team, and has for now almost 15 years run corporate HR, and really in the Raychem style of hiring high caliber people, hiring very good technologists, hiring very good people to be able to be the face of the company around the world. Dieter Roeder used to work for Peter Carson and always told me he learned everything he knew from Peter Carson about how to do good strategic selling. He built the automotive business up to almost a $500 million automotive business for Littelfuse. Carsten Fock was one of his team in Germany. He's now vice president of automotive electronics. Bharat Shenoy is a great example of Raychem hiring those junior military officers that we did so often every year, going and getting people who are just coming out of the Navy, as an example. In Bharat's case, being a submarine officer, came into Raychem as a field application engineer, became a sales manager, now runs all of the product management for Littelfuse. And Boris Golubovich is a guy who worked in Polyswitch, an MIT PhD, now doing all of the marketing and development for new products. So we managed to build a core team of very senior people at Littelfuse, as well as people around the world, like Henry Chen in China. At one stage, I counted we had 20 ex-Raychem people before we acquired the Polyswitch business. So I think sometimes when you're making an acquisition, do you really understand it? Are you ready to receive it? Do you know how to integrate it? Do you know really how it works? So we decided to when we were able to make that acquisition of the Polyswitch business from TE, I think we had the credentials to say this will be a good place for this business. Next, Jim. So we acquired it in 2015. It was completed in March of 2016. We got some very talented people, 30 years of experience. The revenues at that time were about $190 million. By then, they had moved a lot of manufacturing to China, so in Kunshan and Shanghai. And the market had really moved quite strongly to Asia, so there was a very strong Asia presence for sales. We had a good sales team there, and manufacturing in Japan for the Japanese market. Also gave us some very good relationships, which frankly was a struggle for Littelfuse to find those relationships that Raychem had developed through people like Jun Ishioka over the years in Japan, of many, many years of good experience. So we got those very good customer relationships in Japan, and then that takes many, many years to develop, and frankly, Littelfuse, we had not managed to do that in the way that Raychem had done that. Next, Jim. So, you know, we took it back to the name of PolySwitch. You can put the rest of the bullet points up there, Jim. We expand the portfolio of products. We've made a lot of progress on integration. And now I'd say we're still investing as, you know, we see the world go from analog devices to digital devices, and we see USB cables going to the USB Type-C, much higher speed, much more power. You know, there's now the phase of protection for digital circuits. So those are the new products that we've recently brought out for digital temperature sensing. And we have a whole range of new products that we're investing in both here. We moved off the main campus. When we bought the business, we got the R&D building where the last PolySwitch people were camped out. We got all of the equipment from the R&D building. We got a new facility over in Fremont. We opened it up, built out the lab there, and the people now work over in Fremont, together with Fremont and Japan and France and China. The product development teams are working on products for the future. It's a very healthy, very profitable business, and we think it integrates very well with Littelfuse. So I think it's a good ending for a lot of the people around the world, and you know, we think that we've managed to bring some Raychem culture and Raychem history into the company and make it more successful. So that's our story, and if you have any questions, we've got Chet for the early years, Achilles for the TE years, and me for what's happening right now. So thank you.
Any questions? That was pretty.
Sorry?
You have a power switch and one power?
Yes.
Yes.
But it must be very small because there was a photograph back in the houses.
Yeah, the products are now extremely small. One of the things in our strategy that I showed on the slide.
Gordon?
Yeah, one of the things in our strategy was back in '95 was that we expected the products would get much smaller. And you know, one of the rules I learned from Chet Sandberg when I first came here, he said, when you're thinking about the cost of something, you put it in your hand, and if it doesn't weigh very much, you're not going to pay very much. You know, it seemed fairly basic, but electronic component costs have gone down, and size has gone down, and there's just a continuous expectation that everything will get smaller, will get lighter. If it's in a wireless device, that it will last longer in the sense that the battery life needs to last longer, and it's also got to cost less. So those are the natural demands of that marketplace. It's not a place where you get the chance to put prices up.
Any other questions? Okay. First, I think that's a great example of Raychem technology that continues. The name changes. We're going to have the next meeting, we'll talk about nVent. Does anyone know what nVent is? It's Chemelex. There used to be Chemelex, then it became, as part of Raychem, then it became Raychem HTS under Gordon, then Tyco Thermal Controls, then Pentair Thermal Management, and now nVent. And you know what? It's still Chemelex. It's the same technology. So Chet's going to talk about all the work he did at getting the IEEE Milestone Award, which is an incredible thing. And thanks to Chet. But that'll be the next discussion, and it will be, put the glasses on, January 28th, 2020. Holy crap. So I thank everybody for coming. One thing I'm asked is, let's try and get some more people at this. So call your friends before the next meeting and let's get some more attendance. They're starting to make it a little more difficult here, and we need attendance to financially make this work. Thank you, everybody. Appreciate it.